All right, lesson 11.2 is arithmetic sequences and series. Now remember yesterday, or in the last lesson, we learned that a sequence is just a series of numbers that follow a pattern. A series is when you actually take that sequence and you add the numbers up. Okay. Today you're going to actually learn what an arithmetic sequence is, and in an arithmetic sequence, it actually the pattern will always be exactly the same. Okay. And what makes it arithmetic is when you actually it's the difference between two consecutive terms is constant. Okay. In other words, it has a common difference. Okay. It could be a positive, it could be a negative. So in other words, if I gave the number 3, 5, 7, 9, and 11, that would be an arithmetic sequence because each time I'm adding 2, and I add 2, and I have to add 2, okay? Now, I can go back the other way, and if I go back the other way, they call the common difference is because it's the difference between two consecutive. So if you take 9 minus 11, you get 2, okay? Negative 2. If I go this way, it's a minus 2, okay? So that's what the actual difference is. That difference between the two, we're going to denote it with a D, but that common difference, the 2, is the difference, okay? And I usually take like 5 minus 3 gives me 2. 7 minus 5 gives me 2, okay? Now, if I were to do, like if my sequence was 4, 2, 0, negative 2. All right, so basically the difference is I'm going to take 2 minus 4 and I get a negative 2. So in this case, my common difference would be a negative 2, okay? So let's take a look real quick at just determining if it's arithmetic. If I can add numbers to the same number each time, then it's arithmetic. So, for example, if I do 1 minus, we could do 5 minus 1 gives me a 4. So I know the difference between here and here, I'm adding 4. So negative 3 plus 1, yeah, I'm adding 4. 5 to 9 gives me a 4. 9 to 13, I'm adding 4. So my common difference in this case would be 4. And whenever you're adding a number each time, then that is called, yes, that is an arithmetic sequence. Okay? Now, on this one, remember, to be an arithmetic, we have to add. So if I go here, I've got to add 3. 5 to 10, I'm going to add 2. I'm going to add 5. To go from 10 to 17, I'm adding 7. So even though there's a pattern to this, I'm adding 3, I'm adding 5, I'm adding 7. The next one I'll add 9. Next one you would add 11. Because it's not constant throughout each one of them, each term is not the same, then that is going to be, because it's not constant, then it's not arithmetic. Okay? That's the basic difference. It's just that simple. Okay? So let's take a quick look at finding the term. Now, the nice thing about this is if I had 3 pieces of information, I could find any term that I wanted to in a sequence. This could also help me write a more general rule than this. But in each part of this right here is going to stand for the nth term. Okay? So in other words, if I'm looking at a series, 2, 3, 4, 5, 6, okay? My common difference is 1, but this one is the first term, the second term, the third term, the fourth term, the fifth term. So if I was referring to this as the fifth term, this is what I would put in that spot, okay? A sub 1, this little 1 here indicates, because this little n here tells you what term you're looking for, okay, the n. So whatever number that is, that tells us that's what term we're looking for. So in this case, this would be the first term, okay? And then the n tells us, the n indicates this is the number of the term, okay? So in other words, if it's the first term, it's going to be 1, the second term 2, the third term 3. If it was the 18th term, the number would be 18, okay? And then D stands for that common difference. Okay? So that's basically the things you're going to be looking at on that formula. Okay? So let's go ahead and take a look at this. So the next example, so remember our formula. So real quick, remember a sub n is our whatever term we're looking for. So in this case it says find the a sub 20. So we're looking for the 20th term. So whatever that 20th term would be, that's where the 8 would go in the a sub n. The a sub 1 is our first term, because the little 1 here indicates I want the first term. This indicates whatever number I want, the term number, the term. And this indicates the common difference. So we want to write a rule for the nth term in this sequence, and then we're going to find a sub 20. So if I want to write a rule, the first thing I'm going to do is I got to start with my formula. Okay, and I want to know each of these pieces, what are they? Oops. Okay. So a sub n, that's going to be our nth term. Okay, so we don't have that at this point. Our a sub 1, our first term in the sequence, is 50. Our n, well, we're actually looking for the nth term. So we're going to leave that as n, because it will change depending on what term we want. And our common difference, remember we have to go backwards. So 44 minus 50. Let's do that real quick. And make sure you put it in the calculator correctly. Remember, it's 44 minus 50, which gives us a negative 6. So our common difference is a negative. The other clue that tells you that it's got to be a negative is the fact the numbers are going down. Okay, because remember, we're going to add a negative 6 each time. So the rest of this is we're going to plug it in and clean up. So we're looking for a sub n. A sub 1 is 50. Oops. A sub n is 50, and then it's plus. N, we're going to leave it as an n because we're looking for the nth term. Okay, if we were looking for a specific term, we would put that in there. Minus 1, and then our common d is negative 6. Okay, and we're going to distribute this only to the stuff inside the parentheses. So our a sub n is 50 plus negative 6 times n is negative 6. So let's turn this to a negative 6 minus 6n. Negative 6 times negative 1 gives me a plus 6. And then I can just combine my like terms. So a sub n equals negative 6n plus 56. Okay, so that's basically all I would do with my rule. I plug in my a sub 1, I plug in my d, and then make it a sub n equals, just simplify it. Okay. And then combine my like terms. So when I'm looking for the a sub 20, all of a sudden the only thing that changes is now my n is 20, because I'm looking for the 20th term. So a sub 20 is going to be negative 6, n is 20, plus 56. So negative 6 times 20 gives me 120, plus 56. So I find out that my a sub 20 is negative 64. Okay. All right, so go ahead and try the next one. The next one is a U try. We want you to write the nth term in this sequence, and then after you write the nth term, we want you to find a sub 12. All right, so remember we got to start with our formula. Oops, let's try this again. Let's drag this down, and we're just going to plug in everything we know so far. So a sub n, that's what we're actually looking for. We're looking for that nth term, so we're going to leave it a sub n. A sub 1 is the first term, so we're looking for 32 plus. Remember, we're looking for the nth term, so we're going to leave n. And this number here and this number should match. Okay? Minus 1, and we got to find that common difference. So remember, all we're going to do, we got to go backwards. So it's 47 minus 32. Gives us 15. Okay? So that common difference is 15. Okay? So a sub n equals 32 plus distribute 15n minus 15. 32 minus 15 gives me 17 plus 15n as my rule. Okay, so now the directions say find ace of 12. So when I find ace of 12, remember the n is 12, so 17 plus 15 times 12. So 17 plus 15 times 12 gives me 180. Add those up, and I get 197 as my ace of 12. Okay? All right, well, let's take one a little bit different. And let's say I wanted to find the rule. But I know that here's the information that I know. It says one term of an arithmetic sequence is ace of 12 equals 30. The common difference is d equals 3 over 2. Write a rule for the third term. Now here is one suggestion that I would make. You can use 3 over 2. And I would suggest that if the common difference is a fraction that doesn't reduce to a decimal, but 3 over 2, we can simply write that as 1.5. And 1.5 is going to be a whole lot easier to work with than 3 over 2. So, I guess, okay, so when we're writing these, remember we start with our formula. Ace of n equals ace of 1 plus n minus 1 times d. So the problem is, the information that I have is, I don't have ace of 1. I do have ace of n, and ace of n is actually ace of 12. Okay, so whatever that number is, and this may be kind of a hard concept for you to get, because in this case, my ace of n is going to be 30. My n in that case is 12. So in other words, remember, it's the 12th term. So whatever this number is and this number should be the same. So this is the actual term that I'm looking for. Ace of 1 is what I'm looking for, what I need to finish out my rule. Plus n is 12 in this case, so 12 minus 1, and my d is 1.5. So the very first thing we got to do is we got to find that first term. So I get 30 equals, we're going to ace of 1 plus 11 times 1, or 11 times 1.5. So 30 equals ace of 1 plus, and 11 times 1.5 gives us 16.5. So then subtract the 16.5, and we get 30 minus 13.5 for our ace of 1. Okay. So when I'm writing the rule, now I'm just going to plug in everything. But remember, I'm writing for the nth rule, so it's going to be ace of n equals, and this is exactly what we did. Well, ace of 1 is 13.5 plus n is going to stay exactly what it is. Because we're looking for the nth term, minus 1 times 1.5. So let's distribute it. Ace of n equals 13.5 plus 1.5n minus 1.5. So 13.5 minus 1.5 gives me 12 plus 1.5n. Okay. All right, part 2 of this unit, or this lesson, is finding the sum of a finite arithmetic series. Now remember, series means, when I see the word series, means find the sum. Okay? And finite just means that it's going to stop. Okay? It doesn't go, an infinite means it goes on forever and ever and ever, and it doesn't ever stop. So finite means that it's going to stop. So whenever I want, and the other thing, if you notice in the formula, it's S. Okay? And this stands for the sum of the first n terms. Okay? This is the number of terms. So in other words, if I'm looking for the sum of the first 10 terms, that number is going to be 10. Okay? This is going to be the first term. And this right here is the It's the last term in the sequence. Okay, remember it's also known as the nth term. So in other words, if I was looking for the sum of the first 10 terms, that would be the 10th term then, okay? And just refers to however many we want, okay? All right, so real quick, let's go ahead and let's do an example of, consider the arithmetic series, 4 plus 7 plus 10 plus 13 plus 16 plus 19. Now remember, the plus signs just indicate that this is actually a series, and we want to know the sum of the first 30 terms. So we're actually going to look for S of 30. So my n in this case is just the number of terms. So in this case it's 30. My a sub 1, well, the first term is 4. And a sub n is actually going to be a sub 30 because I need that last term or the 30th term in the sequence. Now the problem is, here's the first, the second, the third, the fourth, the fifth, and the sixth. So I have the first 6 terms, but I don't have that 30th term. So what I actually need to do is, I actually have to use the other formula. So remember, the a sub n equals a sub 1 plus n minus 1 times d. Okay, this is all formula driven, so if you can keep your formula straight, most of it's just plugging it in and finding what the answer is. So it's not real difficult. So a sub 1, remember that's your first term, which is 4, plus n, well, we're looking for the 30th term. So n is just the number of the term, so it would be the 30th term, minus 1. And we got to find our d. So remember, we're going to take 7 minus 4, and we find out that our common difference is 3. And it is consistent. 10 minus 7 is 3, 13 minus 10 is 3, so the common difference is 3. So it ends up being 4 plus 29 times 3. Well, 29 times 3 gives me 87, plus 4 gives me 91. So now I have all the components that I need for the formula. So if I'm finding the sum of the first 30 terms equals, my n is 30, my first term is 4, plus a sub n, or the last term, is 91, and I'm just going to divide that by 2. So following the order of operations, 4 plus 91 gives me 95, divided by 2 gives me 47.5. And then I'm going to multiply that times 30, and I get 1,425 as my answer, okay? So go ahead and try the next one as a you try. So this is, consider the arithmetic series 20, 18, 16, and 14, and we want to find the sum of the first 25 terms. All right, so when we're looking at this, remember, we're looking for the sum of the first 25 terms. So your n is 25 terms, so I'm looking for 25. Your a sub 1, first term is 20, and I need a sub n. Well, again, I've got the first, the second, the third, and the fourth term. I don't have that 25th term. So we got to use that formula. A sub n equals a sub 1 plus n minus 1 times d. Well, first term is 20. My n is 25 minus 1, and we got to find the d. So 18 minus 20, remember, since we're going backwards, that's going to be a negative 2. Okay, so if I take 20 plus negative 2, I get 18. 18 plus negative 2, I get 16. So that common difference is negative 2. So I get 20 plus 24 times negative 2. So it ends up being 20 plus a negative 48. So that last term is actually going to be negative 28. Okay? So now that I've got all my pieces, I can find the sum of the 25th term, or the first 25 terms. So my n is 25. Take that times 20 plus negative 28 was my a sub n, and divide it by 2. So 20 plus negative 28 gives me negative 8. And then divide by 2, I get negative 4. So 25 times negative 4 gives me negative 100. That's my answer. Okay? So remember, the two things that you've got to remember, there are two formulas that you have to remember as a recap. Okay? If you're looking for just the nth term, a sub n equals a sub 1, the first term, plus n minus 1. And remember, n always just indicates whatever term we're looking for. The 25th term, the 30th term, the 8th term, 8, 25, whatever that would be. Okay? This is that actual term. When you're looking for the sum, it's s of n equals however many terms we're looking for, times the first term plus the last term, and then divide that by 2. Okay? All right. Good luck.